we present ReLoo, a method to reconstruct 3D humans dressed in loose garments from monocular video in the wild. Given a monocular RGB video, we reconstruct the detailed 3D surface geometry and appearance of clothed humans who are dressed in loose outfits. Digitalizing clothed humans dressed in highly dynamic loose garments from monocular videos is challenging. This is because loose clothing can exhibit large, non-rigid surface deformations during articulation, which often go beyond the scope of traditional skeletal deformation. Most existing reconstruction methods fail to provide convincing results of humans dressed in loose garments, due to a strong reliance on skeletal deformations derived from the underlying body model. In this paper, instead of representing the body and clothing together with a single function, we propose to model and deform them separately. To this end, we establish a layered neural human representation that decomposes clothed humans into an inner body layer and outer garment layer. In the garment layer, we further introduce a non-hierarchical virtual bone deformation module that can accurately capture non-rigidly deforming loose clothing. We learn the layered representation and the virtual bone deformation module from images. Specifically, taking a video frame as input, we sample points along the ray for the body and clothing layers as well as the background. We warp sampled points for the body layer into canonical space via inverse LBS, using bone transformations derived from the estimated body models. We deform sampled points for the garment layer into canonical space via inverse warping, based on the proposed virtual bone deformation module. Note that we learn the virtual bones and the deformation field on the fly during training without requiring a template. We then query the corresponding sign distance and radiance values. We composite the neural body layer and garment layer to obtain the final closed human model, and apply multi-layer volume rendering to acquire the final rendered pixel color and segmentation mask. We compare the rendered color predictions with image observations as well as a segmentation mask obtained using SAM, and jointly optimize the shape, appearance, and deformations of the inner body and outer garment layer. We compare our method ReLoo with existing state-of-the-art approaches for the task of 3D surface reconstruction. We first show a comparison on our monoloose dataset. All baseline methods struggle to recover complete human surfaces. They also produce less details and artifacts, such as the discontinuities between legs. In contrast, our approach reconstructs complete and more detailed dynamic clothed human geometry with temporal consistency. We consistently observe higher quality results on other datasets, such as DynaCap shown here. Our method reconstructs detailed 3D human models with plausible surface details and deformations. We also show qualitative comparisons on in the wild videos. ReLoo performs consistently better than other baseline methods and is robust even with complex human motions. We further conduct comparisons with the template-based method. Our method doesn't require template meshes and can handle surface topological changes, such as the cut in the front of this dress shown here. ReLoo achieves reconstruction results with higher fidelity. We also compare our method with the state-of-the-art approaches on novel view synthesis. Our method, ReLoo, achieves more realistic and plausible clothed human renderings under unseen camera views, especially when garments exhibit large deformations. We show more qualitative results of our method on monocular videos. Here we render the body and garment layers separately. Our method accurately decomposes the clothed human into inner body and outer clothing, achieving high-fidelity 3D reconstruction results to different loose garment styles, human motions, and shapes from only monocular inputs. In this paper, we present a novel layered neural human representation, disentangling the inner body and outer clothing, and a virtual bone deformation module that is built on top of the layered neural human representation and accurately tracks the large surface dynamics. And ReLoo, a robust framework to achieve high-fidelity 3D reconstruction of humans, dressed in loose garments from Monocular in the wild videos. Thanks for watching.